All right. Good evening, students. My welcome to you and very important lecture going on alcohols and phenols. Last time we have shown you the important chemical reactions of alcohols, and I was talking about oxidation. Oxidation is very important, and we have told different type of oxidizing agents are used depending on mild oxidation, strong oxidizing agents, and we have told you about PCC, Jones reagent. They are very good oxidizing agents. Then we have shown that strong oxidizing agents are there like KMnO4, and also dehydrogenation by copper was also done, and questions were also solved, students. And we told you what is denatured alcohol, why methanol is poisonous, and what is its effect. So today is a topic for the phenols, student. Phenols we already have told you. When we talk of phenols, students, what we are talking is phenols. And we will be discussing, students, the reactions of phenols. Important point to note is, students, that you have, this is my phenol. Okay? Keep on interacting with me and keep your energy high. There are two lone pair of electrons on the oxygen, students. Yes. And what happens? This is a lone pair and conjugated system. So what can happen? Benzene can easily take these electrons. What happens then? The result we have shown such a thing is always possible, student. And the result of this is what we have told you in phenols. What happens, students, if you have this type of shifting? What will happen, students? If you get this positive, if you get this negative, what is the result of that, students? What is the result of this? What we are trying to show you, students, that there is a shift of the this lone pair of the electrons, which we have already told you. What happens, students? The shift of the lone pair of the electron is taking place. The result of this is, you can see that what is the result of this. This is a pi electron, which is 2 electrons, and what will happen then? This negative charge is generated, and further this reaction can go. What will happen, students? You know that conjugated system, they will show resonance. Whenever there is a lone pair of electron and an atom, that we know benzene can take those electrons. It has a system by which it can withdraw these electrons. It can act as an electron sink. The result of this is separation of charges, and you will see what we are trying to show you, students, that here what is happening. There are 2 lone pairs. I can still show it, no problem. So what is the result of this, student? If this goes here, then such a situation is arising where more resonating structures are possible. What is happening? That there is a negative charge. On what position you are getting negative charge, students? What is the result of this? The OH group attached to benzene ring, student, is doing what? What I want to say, the OH group, when it is attached to benzene ring, what is the result? First, what happens, student? It will activate the benzene ring. It will activate the benzene. Is producing negative charge at which position? Ortho and para. Therefore, I can say that the OH group is ortho para directing group. For what? What type of reactions? Electrophilic, aromatic substitution. What we call them? Electrophilic aromatic substitution. I hope you understand what I am trying to say, students. There is a negative charge, so what type of reagents are going to get attached to its, students, and at what positions? At what position and what type of groups? Electrophiles. What are electrophiles? E positive reagents. This is negative, so they are going to be get attached to it. they will remove one H and they will get attached. That is why we are saying electrophilic aromatic substitution. This is going to take place at ortho and para position. So it will direct the incoming group to come and attach at ortho and para position because of the resonance. This is what type of resonance, student? बताइए कौन सा resonance चल रहा student? What type of resonance is this? We have told you plus R and minus R. What type of resonance is this, students? The OH group is what type of group? Plus R effect. What it is showing?
Yes, sir.
Plus R effect. So ortho-para directing and the reaction is going to be facilitated, and this will become fast as because OH group is releasing the lone pair of electron is being withdrawn by the benzene, and this is happening at ortho. We can draw one more if you want, no problem. Again, we show it at ortho and para position. So at ortho and para position, what is happening? Negative charge is generated. The incoming electrophile will get attached at ortho and para. So you are likely to get two products. What products you are likely to get, student? Mixtures. What type of mixtures you will get? Ortho and para.
Para, yes, sir.
So you are going to get two isomers. And these reactions are important students. So, and there is an activation by the OH group towards electrophilic aromatic substitution. Active because it is releasing the electron pairs. So it is activating the benzene ring as well as ortho and para directing. Therefore, students, certain questions will become very, very important, and examples of electrophilic aromatic substitution reactions of phenols. Aromatic, one question is likely to be asked on this. This will become important, student. Electrophilic aromatic substitution reactions of phenols. One of the easiest thing you do, you already know nitration, student. You are aware of nitration. What is nitration, student? If you will take phenol, you don't have to add very strong acid, even with dilute nitric acid, because OH group is activating group as well as ortho-para directing group. If I will add a dilute nitric acid, students, then it will produce NO2 plus ion at low temperature. The temperature is usually low. It could be around 298 Kelvin. 298. It is a low temperature. Then what is the result of this? You are going to get mixture of student. It is a question here now. What you are getting? A mixture of ortho and para nitrophenols.
Yes, sir.
Now a question is usually asked on this. This is ortho nitrophenol. This is para nitrophenol, students. The question is which has a lower boiling point, and one of the two isomer. How do you separate the separation of these two? Product 1 and product 2. You are getting two isomers. Separation of these two is a question in the paper, student. How to separate ortho nitrophenol from para nitrophenol is important, student. Which is having a lower boiling point out of the two, which will have a lower boiling point. Separation means that we will be using students boiling point separation. That means we are talking of distillation. Here they use steam distillation. There are many types of distillation, you know, or in organic chemistry, student. And here I'm talking of steam distillation. The question is which of the two isomers will undergo steam distillation? That is our question to you. Question. Every time I say that we are giving talks to you, there are question answer for the exam. Important questions are discussed every time. We should be able to answer them. And here, after we finish the course, we are likely to discuss the important question of each and every chapter with you. So what is the story, students? Tell me which will be having lower boiling point. The one which will be more volatile will undergo steam distillation. Which of the two will have a lower boiling point? Orthonitrophenol or paranitrophenol? You have noted down everything or you are noting down? Tell me.
Copying, noting,
Okay,
noting.
okay, note down. Note down. This question has been asked so many times, students, so many times.
Done, sir.
Okay. The question is orthonitrophenol and paranitrophenol. Which is more volatile? Or in other words, which has a lower boiling point? What is your answer, students? What is your answer? And on what basis you will give the answer? What is you are looking for? When we were talking of boiling points in organic chemistry, what we are talking? That how closely these molecules are associated with each other. As and when hydrogen bonding took place, you know that the boiling point increased. Yes or no? You know,
Yes, sir.
alcohols have higher boiling point than ethers. Alcohols have higher boiling point than hydrocarbons. Alcohols have higher boiling point than aldehydes and ketones because of the strong hydrogen bonding which takes place between the alcohol molecules. Here, what is happening? Is there any hydrogen bonding going to take place in these cases? Yes or no? And what type of hydrogen bonding? Because it's an important question. Important question, student. For example, if I write, if this is my nitrophenol, this is my nitrophenol, this is my orthonitrophenol, orthonitrophenol. And what is my paranitrophenol? If I write paranitrophenol, something like this, students. See this from this list, and I'm writing OH. I'm writing N double bond O, and then I'm writing HO. Why do I write like this? Why do I write like this, student? It should be clear to you. What is the purpose of that? Okay, now what is the story? This is my para, and that is my ortho. Why did I write like this now? Can you see hydrogen bonding where it will take place? Where the hydrogen bonding is taking place, students? Here you see this is negative, this is positive. So what can happen? You can have hydrogen bonding, and here what is happening? This is positive, this is negative. So there could be some hydrogen bonding here. And what is happening? This is negative, this is positive. Here what is happening? Can you see the hydrogen bonding, students? What is the difference between this hydrogen bonding and this hydrogen bonding? Tell me, what is this called? Within the molecule, intramolecular hydrogen bonding, student. Within the molecule, student, within the molecule. And what is this called? Intermolecular hydrogen bonding.
Bonding, yes, sir.
Which will have a higher boiling point? The question is this. This will have a higher boiling point or this one now? Because we have shown you what type of hydrogen bonding is taking place. This is within the molecule, but it is not associating with other molecules. So what will happen? This will become volatile, lower boiling point, and
Yes, sir.
undergo steam distillation. And this will, because there are the intermolecular hydrogen bonding, students, this will have a higher boiling point. Therefore, by the difference in boiling point, students, it is possible to separate them. Therefore, we can say that orthonitrophenol is steam volatile it is steam distilled, it is low, having more volatile because of the intramolecular hydrogen bonding, and this will have a higher boiling point. Therefore, the two can be separated, student, by the method of, they can be separated by steam distillation. This was a question in the paper, so I hope it is clear.
Yes, yes, sir.
Note it down, then I proceed further, students.
I'm copying the 2 minutes.
Okay, important question, student. Whatever is important has to be discussed for the exams, for the exam.
Yes, sir, copied, sir.
Okay. This was the story of the dilute nitric acid, because you already know that what happens is that OH group we activates the benzene ring towards electrophilic aromatic substitution reaction. And if I add concentrated nitric acid, students, what will happen? Concentrated HNO3, you will get a very important compound, student. What is the name of this compound, students? What is the name of this compound? Right, this is called picric acid. What is this? 2,4,6 trinitrophenol. 2,4,6 tri 1,
Yes, sir.
2,
Picric acid.
3, 4, 5, 6, 2,4,6 trinitrophenol. Now this picric acid, this is a strong acid, student. This is a strong acid. Why it becomes a strong acid? Tell me. We have discussed the acidity and is important question for the exam. Why picric acid is a strong acid? Why picric acid is a strong acid? There are nitro groups present at 2, 4, and 6 position. There are 3 NO2 groups which are present at ortho and para positions. They are strongly electron withdrawing groups. Strongly electron withdrawing groups, students. So
Yes, sir.
what will happen once the phenoxide ion is formed? They will resonance stabilize it. The phenoxide ion will be highly resonance stabilized by the 3 NO2 groups by means of the minus R and minus I effect. Minus R, minus I effect. What will they do? Stabilize the phenoxide ion. Therefore, they are, it acts as a strong acid. Very important question. We already know about that. Okay, next reaction we are coming, which we call as halogenation with bromine. Br2 student, bromine, water. If I take phenol students, and react this with Br2. What I have? Br2 in carbon disulfide. Student, in carbon disulfide, 270. Temperature is low. This is a solvent. This is a solvent, student. Then it becomes dilute. What you will get? Mixture of the products. Mixtures of the products are obtained, student. What are those? Ortho and para. Which will be the major product, students? Ortho and para. Which will be the major product? Tell me. Orthobromophenol and parabromophenol. What is going to be the major product, students? Always we have told you, para will be these are the major products. And this is the minor products. These two groups, as they are further away, repulsion is minimized. Repulsion is minimized. So this will be the major product. This will be the minor product, students. You can note down, students. You have noted. I will proceed further, students.
Yes, sir. Copy it, sir. Copy it. Copy it.
Okay.
So copy it, sir. Copy it. Copy it. Please proceed.
Okay. This was your Br2 in the presence of carbon disulfide, student. If I react with bromine water, then what happens? If I have phenol, students, if you react with bromine water, Br2, student, bromine water, then this is a concentrated solution of bromine, student, concentrated solution of bromine. The result is that OH group is strongly activating the benzene ring at ortho and para position, student. You will get 2,4,6 tribromophenol, 2,4,6 tribromophenol. So 2,4,6 tribromophenol will be obtained. It is a white precipitate. These are all electrophilic aromatic substitution where you have Br plus and NO2 plus attacking reagents here. Important reaction, student. This reaction has been asked in the paper many times. Complete the reaction. For example, such questions are given. Now we're coming to another important set of reactions, which one of the two is coming, for which mechanism, etc. we have already uploaded in the YouTube, student. Important name reaction now. Name reactions are always important for the exams because there will be questions on them. Important name reaction, students. And one I am talking of Kolbe'S reaction. Kolbe'S reaction, student. What is Kolbe'S reaction, student? Kolbe'S reaction is a reaction in which they will say, for example, convert phenol to salicylic acid. Before I do that, I should know the formulas of this phenol. Phenol formula, I know what is the formula of salicylic acid, student. Important reaction for the paper. What is the formula of salicylic acid? I give you 30 seconds for answering that question. Do you know the formula of salicylic acid? What is the formula of salicylic acid? You know what is benzoic acid?
Yes, sir.
And what is this? These are 2-hydroxybenzoic acid.
Okay.
Where is benzoic acid, student? This is my phenol. This is my phenol. Now I am introducing a COH group at ortho position. At ortho position. See that? This compound is called salicylic acid 1, 2. Ortho-hydroxybenzoic acid 2-hydroxybenzoic acid. Right or wrong? Tell me. What will be the
Right, sir.
IUPAC name? 2-hydroxybenzoic acid is an important compound because this compound is used for what purpose? You know where it is used for?
No, sir.
This is used for the preparation of aspirin. Do you know what do you use aspirin for? This is acetyl.
Sir, yes, it's a medicine.
What medicine you are using, student? Sally. I will put it like this. Salicylic acid is called salicylic acid. Acetyl salicylic acid is called aspirin. OCHO3. Acetylation is done when we will do the acetylation of this acetic anhydride in the presence of acid hydrolysis. Then what will happen? Aspirin. We will show it and we will be able to prepare it in the coming reactions. Okay, this was just to tell you because such questions are important. Such questions are important. If for the fever, for the headaches, you are using aspirin, students. So what is happening? How the reaction is taking place in this case? This is actually reaction takes place in steps. First, you see, I have phenol. This is reacted with sodium hydroxide, student. What will happen? Then it will become ONA plus. ONA plus, student. Sodium phenoxide is formed. Then this is reacted with, student, is reacted with carbon dioxide, and second step here is H plus, acid. This is acid. What is the result of this, student? Product is salicylic acid. The product is salicylic acid, students. This reaction is called Kolbe'S reaction. Is very, very important reaction for the exam, students. Already in the YouTube, I have uploaded the video. If you want to see the mechanism, you can go through my YouTube channel and you will be able to see 5 to 6 minutes spent and you will see the mechanism. This is important for the exam, I am telling you.
Okay, sir.
Important reaction, important name reaction, I have said. So the reaction is taking place in 2 steps. Now, what is the role of CO2, students? CO2, this is my CO2. Carbon, this is positive and this is negative. This is negative. So what will happen? This is again an electrophilic. Carbon is a weak electrophile. This CO2 is a weak electrophile. Student, C plus positive, you can see that. So then it is also example of what type of this reaction? Electrophilic substitution reaction. This is also example of electrophilic aromatic substitution. Why? CO2 is a weak electrophile.
Yes,
Question has
sir.
been asked here. This question has been asked. But what is CO2? CO2 is a positive charge on the carbon, is a weak electrophile because it is activating the benzene ring. Therefore, it will attack. But why we are adding acid? Because you have ONA. Then ONA, you have to remove Na by H plus, so phenol. First, you will get what will be the product in first product will be here. In the exam, I write only this to show you. You are getting O minus Na plus and here you have COH. So this is basic, this is acidic, you are adding H plus, so what will happen? Then you will get this ortho-hydroxysilicate. This will be replaced by H plus. Or even this possibility is there, that there is a basic group and acidic group. That is why H plus is there. These steps have to be written in the exam, students, in the exam. Got it? So this is our final product. And
Okay,
this
sir.
is used for the preparation of aspirin. Acetylation is done. So you on acetylation of this, you will get aspirin. Ester formation, student, ester formation. Acetyl salicylic acid is that. You have seen the esterification reaction of alcohol student. That reaction I am talking of, esterification reaction of alcohols, have been discussed earlier. Ester in the ester formation. Okay?
Yes, sir.
Noted. I will proceed further. Can I go further?
Yes, sir.
Okay. Another important reaction. There are two important name reactions here. First one I have discussed. The second one is called a Reimer Tiemann reaction. Very important. Name reactions are very important. Mechanism we have already uploaded in separate YouTube. You can go and watch it. Here, this is a reaction on when we will react phenol with chloroform. Student, chloroform.
Yes, sir. Clear, sir.
And in the presence of aqueous NaOH, and what happens is you will get the introduction. This is used to introduce CHO group at ortho position. At ortho position in phenol student. So in this reaction, we will use chloroform plus NaOH. Chloroform plus NaOH is used here. Aqueous NaOH and chloroform is used. Then what happens? Then the result of this is again NaH, it reacts with NaOH. And finally, third step, we always add H plus because sodium ONO is there to get back the OH group. To get back the OH group, student. These are important reaction again for the exam, student. What we have to show in the paper is like this. This is my phenol, and what I am reacting CHCl3 plus NaOH, students. The result of this is what, students? You are having O minus Na plus, O minus Na plus, and here what you get, student? CHCl. This is an important thing. You are getting this. What is this known as? This is an intermediate. This is called benzyl chloride. Benzyl chloride. This is an intermediate student. And this will again react with NaOH. There are 2 moles of NaOH because then this will replace by OH. And then after that, what will happen? You will get, student, O minus Na plus CHO. This aldehyde group this becomes CHO, aldehyde group. Now I have to replace this Na. That is why I add H plus. Then what is the result of this? You will get this compound. What is the name of this compound, students? Can you name it? What is the name of this compound? The common name is salicyldehyde. This is our salicyldehyde. And here this is 1, 2. What will be the name? 2-hydroxy? 2-hydroxy benzaldehyde. You know, this is our IUPAC name. What is happening in the reaction, student? What is happening? What is this? If I see that, you can see the mechanism. As I said, I have been uploaded, but you can see it. What is happening? Hey, OH minus is added. What will it do? You can see there are 3 electron withdrawing groups. And this will then remove this. This will then remove this. What will happen? This OH will take this electron, students, and what will happen then? There will be, and what will be the result of that? If you remove this, you are getting Cl, and Cl, and there is a pair of electrons. Then what happens, student? Then this group will leave. This group will leave, and this becomes OH minus H plus becomes H2O. What will happen? You will get Cl. this Cl minus is left. And this is important. Carbene, this is a electron deficient species. This is a electron deficient species, student, and that is why it undergoes electrophilic substitution reaction. This is a, you can see 2Cl and C. This is a electron deficient species, and behaves like an electrophile. Electrophile. This is also an electrophile, student. Electrophile, which will attack this. See, so this is how the reaction takes place. And then what will happen if you have two Cl group? If you add an NaOH, there will be two OH group on the same carbon. And whenever you will have such a situation, student, what I'm trying to say, if you have this type of compound, this is not going to be stable. It will immediately lose water. And what you will be left with? CHO. See that? These two OH, they will replace.
Yes, sir.
And you know that this is like, we have told you, when two OH groups are present on the same carbon, this is going to lose water very readily, minus H2O immediately. And you will be left with this one. See how the reaction is taking place. In the complete mechanism, we have already shown, student. Complete mechanism, we have already shown, student, what happens. And you are getting this product. See the 2Cl replaced by two OH groups, because there are two NaOH. There total 3 NaOH are used in this reaction, 3 NaOH, and then acid is added to remove sodium 2OH plus. So this is the way the reaction takes place. This is the way reaction takes place. The electrophile is this one here, electron deficient species, which will attack the benzene. Complete mechanism we have already given. You can watch the YouTube. Got it? How the reaction?
Yes, sir. Yes, sir. Yes, sir.
And the exam, all we have to write is this one. That's all. How many steps I have shown? 1, 2, and 3. This one. Okay?
Yes, sir.
Name of this reaction, Reimer Tiemann reaction. It gives aldehyde group at CHO. Kolbe'S reaction gives COH group at the ortho position. See the difference between the two reactions? In Kolbe'S reaction, you used carbon dioxide, which is a weak electrophile. Carbon dioxide is a weak electrolyte. In this case, I have used CHCl3 and NaOH, chloroform and NaOH. So we have to remember these, students. There is a way of learning the reactions. So you will learn these reactions. Very important. Okay. After
Yes, sir.
down, I will proceed further. Can I proceed further, students?
Yes, sir. Yes.
Okay. So further important reaction of phenol with, another important reaction of phenol I'm talking of, when what happens, reaction of phenol with zinc dust. Important because student, zinc, you know, is basically a reducing agent. And it has a great affinity for oxygen. It will take the oxygen if ever it gets opportunity. You know that, you already know the E naught value of zinc minus 0.76 volt. So
Yes, sir.
very common reducing agent which is used in the organic chemistry also. So if you want to convert phenol into benzene, question like this, convert, question now, question, convert phenol into benzene, student. So what will I do? I will react phenol with zinc dust. Phenol is treated with zinc dust because powdered zinc is more active, and zinc will take this oxygen immediately from it. What are you left with, students? This is your benzene.
Yes, sir.
So one-step reaction, important reaction, fun time for the exam. Want to convert phenol into benzene, add zinc powder, and you will get this reaction. Just you have to heat it. Another important reaction, oxidation of phenol, students. Sometimes they give you and say complete the reaction. What happens? You have phenol, students. And if you oxidize it, sodium dichromate is an oxidizing agent in the presence of acid, then you are getting a compound, student. This is the oxidation. You can see that there are two CO groups which have been introduced. So it produces a conjugated diketone. This is a conjugated diketone, students, important compound. Sometimes questions are given. So phenols are slowly oxidized to dark colored mixtures. This is called benzophenone. Benzoquinone, students, benzoquinone. So oxidation, chromic acid oxidation produces benzoquinone in the case of the phenol, students. You have noted down?
Yes, sir.
Okay. These are the reactions of the phenols which are there in our course for the 12th class. There is more information, but there are some questions here for us to be solved. What are the important questions on this? What are the important questions on this, student? देखो, questions have come to be answered by us. Always I say question answers are very, very important. Wherever questions can be answered, student, question number 1 on the screen. What is it says? Write the structures of student major products expected from the following.
Yes, sir.
First question. You are doing mononitration of 3-methyl phenol. You have to do the mononitration. First, you should write the formula of methyl phenol, 3-methyl phenol, and then you should do the mononitration. What will be the product, students? What will be the product? We have only 1 minute to answer the question, students. Question 1A part. What is the formula of 3-methyl phenol? 3-methyl 1, 2, 3. Methyl group is attached at 3 position. So
Yes, sir.
you are doing mononitration. If you add dilute HNO3, what will happen? Where will the nitro group come? That is an important point to be noted. Where the nitro group is going to get attached to student. What he says, major products. There are 2 products, but he is talking of the give only 1 product. So nitro group can go where? Either ortho or para positions of the OH group. OH group, ortho and para positions.
Yes, sir.
Which is the ortho position? This one, ortho, and this para. Which is the best position for NO2? Because this is NO2 plus, which is going to get attached. Electrophile. What will be the answer? Your answer, students? NO2, if it comes NO2 here, ortho position, there is a repulsion. We told you best position is always where? Para position. So where it should go then? This is activating. So then you have NO2 group at the para position, students. So there is a combined influence of OH and methyl group. OH and methyl groups. Combined OH, there are 2 groups, OH and methyl. Further, what is the second? Dinitration of the student. There is another group here. If it comes at NO2, then what will happen? Then it is also going to be here. Also, there is some repulsion, as you can see.
Yes, sir.
So you can get another product. Another product. Now, what is happening here? Dinitration. Dinitration, student, of 3-methyl phenol. You have OH. Where should the two nitro groups come?
Yes, sir.
Where will I put the two nitro groups? Ortho and para position. Here there will be strong steric hindrance. There are two groups. This is ortho position. This is para position. So they may go at this point. Go at this point. Students.
Yes, sir.
Okay. What is the C part? Mononitration of phenyl methanoate. First, you have to write the formula of phenyl methanoate. The B part. So one C part.
Yes, sir.
Formula of phenyl methanoate. You have phenyl group. And what is that? Methanoate. What is methanoic acid? This is a methanoic acid. You are replacing this group by phenyl group. So how it looks like? O C double bond O, and what do you have? Methyl. What was that? Phenyl methanoate. Then it should be CH3. This is my
Yes, sir.
CH3, and here you have to replace by phenyl group. OPH CH3C. Now, when you will react this with mononitration, what will happen? If I do the mononitration, where will it go? What type of group is this? Ortho position, you see, is a big group.
Yes, sir.
So where it should go then? It should go to the nitro position. OCOCH3. So this should go to the para position. In the exam, you see that we have to try and see what factors are operating, inductive effects are operating, or the groups which are attached, what type of groups they are, the influence of OH group here, and the influence of this group, the influence of methyl group. So where they will direct the incoming electrophile. These are all examples of electrophilic aromatic substitution reactions. Students, electrophilic aromatic substitution reactions. So for example, he says, give the products you would expect from each of the following alcohol reacts with. Now what happens when this reaction takes place? If I have to do 11.6 question, what is Phenol, student? CH3, CH2, CH2OH. And when you react with HCl zinc chloride, you have seen what is the result of this. This reaction was used for the preparation of haloalkanes. Haloalkane, students. So what will happen? OH group is replaced by Cl group. What is the product then?
Yes, sir.
These are the reactions which you have already done. You have HBr, then what happens? Then again, you will replace these OH groups by Br. Then thionyl chloride, you know what happens? OH group will be replaced by Cl. And if you have 2-methyl butanol, what is 2-methyl butanol, student? 1, 2, 3, 4. 2-methyl. 2-methyl. This is 2-methyl butanol. Okay?
Yes, sir.
2-methyl butan to all. 1, 2, 3. How many carbons? Becoming more. I only need 2-methyl butanol. ठीक है. 1, 2, 3, 4. ठीक है. 2-methyl butanol.
Yes, sir.
So if I react with HCl, this will be replaced by Cl, Br, and Cl. This is a 3-degree alcohol. 3-degree alcohol, this reaction will be very fast as compared to this. So we can easily write the product, students. And then we talked of major acid catalyzer dehydration. When we do the dehydration, for example, in 11.7, what is that compound, student? 1-methyl cyclohexanol.
Yes, sir.
Cyclohexanol. This is my cyclohexanol, and there's a CH3 group here. So what can happen if I will do the acid catalyzed dehydration? OH and H will go. OH and H will go. Where is the H? There are, see, 2 hydrogens here. If it goes, then you can see that there will be a double bond here. Double bond here. There is another hydrogen here. So carbon, next hydrogen, next hydrogen. If it goes here, then same product. Okay?
Yes, sir.
Double bond is coming here. And since he is saying the major product, if this hydrogen and this goes there, this can be a double bond. For example, what I am trying to say in this case, you are saying one possibility is OH and H, then you are left with CH3, this one. You can put double bond here or it makes no difference, they are the same. This has got methyl group attached to the benzene ring. If I write the another product CH2, if you are saying, sir, let me write it like this. If this forms a double bond, then what happens, students? Let me put it this way. Then this is this group, this alkene, but this is less stable. Because there are 2 hydrogens, this is more stable. This is more.
Yes, sir.
Because there is a methyl group, so major product will be this one, and the ash will be only a minor product. See how we do the questions in the paper, students. Acid catalyzed dehydration of butanol. What is butanol? 1, 2, 3, 4. You have OH, you have H, you have H. Here you have H, CH2, CH3. Now in this case only this OH group, or you can remove any of this. What is the product? Then only one product is there. What is that? Alkene, because what you will get on dehydration, water will be out, and this is going to be alkene. What alkene? CH3, CH2, CH double bond, CH2. ठीक है?
Yes, sir.
Name of this product? What is this? Butanol. Yes?
Yes, sir.
Dehydration. The next question, orthoparanitrile more acidic than phenol. You already know the reason for that. Nitro groups are strongly electron withdrawing groups. They will increase the acidity of the phenols. You want to draw their resonance structure, you can do it. We have done it so many times. An important question for the paper, as we have said, write the equations involved in the following reaction. Reimer Tiemann, Kolbe, we have done it just now for you. Can you answer both these questions? Can you answer? Tell me. You can only, you have to write the equations for Reimer Tiemann and Kolbe's in the exam. Will you be able to do it, students?
Yes, sir.
Okay, then this chapter ends. And we will move to the next chapter of aldehydes and ketones in the next class.
Okay, sir.
And you have to practice and do more questions on this.
Hmm.
Okay, then good night.
Okay.
We'll meet you in the next class.
Thank you, sir.
Okay.